वेरी गुड मॉर्निंग, वेरी गुड इवनिंग। तो आज हम करने वाले अपना न्यूमेरिकल एनालिसिस। तो आज है 15 मार्च 2026। इलेक्ट्रिकल मशीन, वन डीसी जनरेटर। तो फ्रेंड्स, आज के जितने भी न्यूमेरिकल्स होने वाले हैं वे सब डीसी जनरेटर पे होने वाले हैं। तो हम स्टार्टिंग बेसिक्स से करेंगे एंड फर्दर हम मूव ऑन करते जाएंगे। मेरे पास एक क्वेश्चंस की लिस्ट है जो कि मैंने बहुत से बुक से उठाई है, तो हम उन्हीं क्वेश्चंस को सोल्व करेंगे। आप अपनी रेफरेंस के लिए इलेक्ट्रिकल मशीनरी बाय पीएस भीमरा या फिर डॉक्टर अस्फाक हुसैन या फिर आप आईजे नागराथ और कोठारी की कोई भी बुक उठा सकते हैं। These are very beneficial books. So starting with first numerical. So first numerical is about EMF equation, where we have so the question is, we have a wave wound armature. First detail we have noticed. Second one is for the wave wound armature of a 4-pole DC generator. Number of poles 4. Has a 51 slots. Number of slots 51. Each slot contains 20 conductor. One slot 20 conductor. And what will be the EMF generated in the machine when driven at 1500 rpm? Here we get the speed, that is 1500 rpm. If useful flux per pole is 0.01 Weber, here we get the flux which is 0.01 Weber. So the EMF equation is phi ZNP upon 60A. So now putting the values, firstly for number of poles P we have 4, number of slots and one slot have 20 conductor, then multiply them, it will be 1020. These are number of armature conductors, that are Z, the speed and the flux per pole divided by 60 is a constant, and here is number of parallel path. As you see, there is no clearly mentioned, but we have wave wound rod armature. When we studied, we discussed that a wave wound armature or a wave winding have two number of parallel path irrespective of number of poles. So when the armature is wave wound, there are actually two number of parallel path. So now doing the calculation, so this will be equal to 2 into 7 into that is equal to 510 volt. So this is the EMF generated. Now the second question, a 4-pole, number of poles equal to 4, 1200 rpm, here we get the speed, and a lap wound armature. And DC generator has 760. Here we got direct conductor 760 conductors. If the flux per pole is 0.02 milliwebers, say here milli is given, so calculate the EMF generated. As we have again the EMF equation, which is phi z np upon 60a. Now see, there is a lap wound armature. In a lap wound armature, the number of poles are equal to number of parallel path. So as there are 4 number of poles, the number of parallel path are also 4. So now putting the values, see it is milliweber. So now doing the calculation, this will be written as 1000 so this is equals to 91.2 volt. This is the EMF generated. Now let's move on to the next topic. Here a machine, a DC generator, a DC shunt generator have 8 number of poles. DC shunt generator, sorry for that, have 8 number of poles, which is running on a speed of 500 rpm. A load is connected to the generator of 12.5 ohm, and the terminal voltage is 250 volt. The armature resistance is 0.24 ohm. The field resistance is 250 ohm. We have to find IA, EG and flux per pole. So IA is the armature current, EG is the generated voltage, and this is the flux per pole. So meet the circuit, and it is mentioned that we have to neglect the brush stroke now, or in this question. .5 ohm. The voltage across is 250 volt. There is no algebra of load current. this is 250 ohm, this is 0.24 ohm, there are 8 poles, and the running speed is 500 rpm. So these are the all things mentioned here. So now what we see, it is the terminal voltage and it is the load resistance. We have resistance and voltage. The load current IL is equal to V upon RL, which is equals to 20 ampere. Now by the question we can see that or we know that the voltage is same when connected in parallel. Here is 250 volt, then it obviously is there is also 250 volt, and also there is 250 volt, and we have the resistance 250 volt here. So ISH is equal to terminal voltage upon RF, which is equals to 250 volt upon 250 ohm. So ISH equals to 1 ampere. Now from the diagram we can see that as it's a shunt generator, it is the direction of current, and IA equals to ISH plus IL. We have IL 20 ampere, IH 1 ampere, so IA is equal to 21 ampere. So the generated voltage is equal to V plus IAR. Here V is 250 volt, IA 21, and RA 0.24. Yes, it's 0.24. So now it is equals to 5.04, and it is 250 volt. It is equals to, I am writing here, it is equals to 255.04 volt. So the generated EMF is equals to 255.04 volt. And now we have speed of rotation, we have generated EMF, we have number of poles. So we can find out the the flux per pole. So in question we have mentioned that it's a shunt generator, and also wait a second, I think I forgot to mention. Yes, the armature conductors are also there. The armature conductors Z are equal to 778, and there are, and it is a wave wound rotor. Wave wound. Sorry, I forgot to mention them. So we have EG equals to phi Z N P upon 60A. We have EG Z N P A 60. So EG into 60 into A upon Z and P is equal to phi. So now putting the values, 255.04 into 60 into 2. As in a wave wound rotor, there are two number of parallel path, the speed of rotation, the number of poles, and number of armature conductors. Now on calculating, we get this, and also so now what we have is to do calculation 255.04 into 3 equal to 765.12 divided by 778800. So now 765.12 divided by 77800 is equals to 0.98 into 10 to the power minus 2 Webers per pole. So this is the question. Sorry for not mentioning them before. From now I'll make sure I speak complete question. So the next question is, a 4 pole, number of pole equal to 4, lap wound DC shunt generator has useful flux per pole of 0.07 Webers. The armature winding consists of 220 turns. Here's the new concept. The armature winding, each of having 0.04 ohm resistance each turn. Now that's something. Calculate the terminal voltage when running speed equals to 900 rpm if the armature current is 50 ampere. Here is armature current 50 ampere. So what we have to do is, firstly found the armature resistance. As firstly what we see is 220 turns and the resistance each turn, so it will be equal to 0.88. Now it's not actually the resistance, cause the armature winding resistance doesn't depend on the number of turns actually directly. It depends on how it is connected by the number of parallel path. As we see, it's a lap wound rotor and their number of poles is 4. In a lap wound rotor, the number of poles are equal to number of parallel path, so there are actually 4 number of parallel path. And if we divide that, say it is actually the, I am taking an example, the 0.88 is actually the equivalent resistance of that resistors, and to break it down we just simply divide it by 4. So now the resistance is 0.88 Sorry. It is 0.88. The equivalent resistance is equal to 0.88 by 4, it will be 0.22. Now firstly find the EMF generated, which is equals to number of poles into useful flux into, there are 220 turns and each turn have two conductor, one turn, two conductor. Say this is a turn, it will go that side, the one conductor, the second conductor. So it is equals to 440. Also the speed is 900 and it is number of parallel path equal to 4. That the first thing, that the second thing. Now the remaining part is just calculation. Calculation. This is equal to 462 volt. So now we have voltage, generated voltage. Guys, I'm thinking of something, that here the actual resistance of armature winding is not just by this. As we see, the number of poles also affect it, and that how much resistance actually lies there. So it will be divided by 4 two times. So now the resistance will be equal to 0.055 ohm actually. Firstly is due to parallel path and second due to number of poles. So now Eg is equals to terminal voltage, armature current into resistance. Eg we have is 462 volt, terminal voltage you have to find out. Ia is given equals to 50 ampere and armature resistance is 0.055 ohm. So now 460 volt minus the product of these two, which is equals to around 2.750, 2.75 equals to V. Now V is equals to 259.25 is, yes, 459.25 volt. Now it's just a simple question. Now for the next thing, we have a 4-pole lap wound long shunt compound generator, which have useful flux of 0.07 ohm, which have 220 turns the armature, the resistance per turn equals to 0.04 ohm, 0.00004 ohm actually, and the shunt field resistance 100 ohm, the the series field resistance 0.02 ohm, the speed 900 rpm, the armature current 50 ampere, and what we have to find out is the same as the terminal voltage. Like it's the upcoming question. We have mostly the same parameters, say the flux, number of turns, armature resistance, the lap wound, the 4 poles, the speed, and the conductors will rise up to 440. So EMF generated will be same as 462 volt. Now the thing is, we have to find out the terminal voltage for a long shunt DC generator. We have to find the terminal voltage. This is EG, the resistance RA, the current IA, the RS. This is ISH, that IL. And actually there is no need of IL. Generated EMF minus IA RA plus RSC. So EG is equals to 462 volt, IA is 50. That thing is we have already calculated, which is 0.055 ohm, and the RS is equal to 0.02 ohm. So it is equals to 50 into 0.075 ohm. Terminal voltage is equal to 462 minus 0.075 into 50, that is equals to 3.75. Terminal voltage is equal to 465 minus 3.75, 46, sorry, that is equals to 0.75, that is equals to 458.25 volt. So we have done 5 numericals till, and it's about half an hour. So the next numericals will be done after some time. We have a break now. Thank you guys.